Today we will be learning about factorials. For some of you this will be new, but for others just a review. A factorial symbol is the exclamation point in an English class, but a factorial symbol in a math class. What does 3 factorial equal to? Well, the factorial symbol says to start at the given number and then multiply by the descending whole numbers until you get down to 1. So we multiply that together, we get 6. So 5 factorial would be 5 times 4 times 3 times 2 times 1. And believe it or not, that's 120. So we now know that 5 factorial is 120 and 3 factorial is 6. So if I divide that out, I get 20. But what if I had not done the previous calculation? I could have written it as 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1, and then reduced the like factors in top and bottom, and still have gotten 20. Why would I want to do that? Well, because when numbers get really big, some calculators cannot do the 108 factorial. It's just too big. It's a huge number. But we can still do this calculation. So we have 108 times 107 times 106 times 105. No, we're not going to write this all the way out, all the way down to 1. Now, why did I stop at 105? Because the denominator starts at 105, and I know I'm going to multiply all that down to 1. So that means all of those are going to reduce out, and I'm left with just multiplying those numbers, which then I would reach for my calculator, and I would multiply 108 times 107 times 106, and look at that. What is that? 1,224,936. So pretty big, pretty fast. But what if you don't have numbers? You have letters. Well, you still need to know how to simplify. So we're going to take these last 2 examples and apply them to this. Which one is bigger, n plus 2 or n? Well, of course n plus 2 is bigger. So I'm going to start out with the biggest one, just like the 108. So n plus 2 would be multiplied by the next lower one. Subtract 1. That would be n plus 1. Multiplied by the next lower one, which would be n. Multiplied by the next lower one, which would be n minus 1, then n minus 2, n minus 3, keep going forever, or in other words, n factorial. Again, why did I stop there? Because that was my denominator. And I know that all of these keep going, all of those keep going. They would all divide out, and I would just have left n plus 2 times n plus 1, or n squared plus 3n plus 2. So that's how you can use factorials in an algebra way. Let's do this next example. I know that's kind of weird. Pick the biggest one, which in this case would be n plus 1 in the denominator. So we'll start with n plus 1, go down, subtract 1, we would have n, subtract 1 again, we'd have n minus 1, and that's my numerator. So I'm going to stop. And I say factorial because remember that just keeps going. That keeps going, but I can stop because those would be the same. There would be a 1 left in the numerator. So I'd have 1 over n squared plus n. Pretty easy, but it might not be something you've ever done before, and you will have to do that in future classes. Now factorials in this particular class will be looked at in terms of combinations. And so we have this symbol. It's read N choose J. Some different textbooks use different letters, but it's the same thing. It's the number of combinations that can be made choosing J objects out of a set of N objects. So let's say you have a square, a star, a diamond, and a circle, and I say how many different combinations can you do by choosing 2 of them. So I would have 4 objects, but I would choose 2 of them. Well, you could list them out Let's see, we could have square and star, square and diamond, square and circle, star and diamond, star and circle, and diamond and circle. Order does not matter. So let's see, how many did I get? 1, 2, 3, 4, 5, 6. I think it's 6. I may have missed some. Well, let's see. So how would I do that? 4 objects, choose 2. If I use this formula, n is 4, j is 2. So we would have 4 factorial divided by 2 factorial, and then 4 minus 2 factorial. Let's just do that math. That's 4 factorial, 2 factorial, 2 factorial. Can I multiply those together and say that's 4 factorial? No. If you multiply that out, let's see, I'm going to come down here. So I have 4 times 3 times 2 times 1 over 2 times 1 and 2 times 1. See, that's not the same. So those divide out. 2 goes into 4 2 times. So let's see, I have 2 times 3 is 6 over 1, 6. Yes, so there are 6 different ways to, if I had 4 objects and I could combine any 2 of them. So if I had 6 objects and I chose 4, that would be 6 factorial, 4 factorial, and I would subtract them and I would get 2 factorial. So I'd go 6 times 5 times 4. I'm going to stop. Why am I going to stop? Because I have that in the denominator and know that's going to cancel out. But this I'm going to write as 2 times 1. So those would cancel, and then I could divide 2 goes into 6 3 times, and I would get 15. So if I had 6 objects and I chose 4 of them at a time, we would have 15 different possibilities. Could I do that for here? Yes, I could write it out the same way, but what about a calculator? Let's investigate that. On the TI-83 and most of the TI calculators, they're all about in the same place. I need 48 first, so I'm going to punch in 48, and then I need to know the number of combinations. Where is that? It's under your Math button, and then under PRB, so I'm going to arrow over to PRB, which stands for probability. And then our third option is NCR. That's the number of combinations. So I'm going to enter that, and then it's waiting for me to say, well, how many objects are you going to choose? 20? Oh my, look at that. That is we're just going to 1.67 times 10 to the 13th. That's an approximation. That means that's a lot. So if I wrote that out, 167, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, that's a really big number. So that's why calculating that by hand or trying to demonstrate that, way too big. But again, on the calculator, it's under Math, under PRB, probability, third options. Different calculators, different places, but it certainly is nice to know that you have that built-in function.